Okay, guys, I started recording this section and I forgot to hit the record button. So let's go over it again. One more time. So section 5.5, constructing a graph from data. So these are criteria for the good graph that we're gonna observe. It says number one, the horizontal axes should be properly labeled with the name of units in the input variable. Number two, the vertical axes should be properly labeled with the same units of the output variable. So remember in the previous example, our input variable was time in seconds, and our output variable was height from the ground in feet. So the units was seconds for the input variable and feet in the output variable. Okay, number three, use an appropriate scale. Start at or just below the lowest value and end at or just above the highest value. Scale the graph so the adjacent tick marks are equal in distance apart. We already discussed that as well. Use numbers that make sense for the given data set. The axes must meet at 0, 0. Use this symbol between the origin and the first tick mark if the scale does not begin at 0. So for example, if I wanted to represent student heights, let's say I asked everyone in the class what height they had in inches. So I would expect that we probably would not have anyone shorter than 140 inches, and then probably not taller than 190 inches. So I want to show all of my data points will be concentrated between 140 and 190, okay? So I don't want to show the empty space between 0 and 140. So in this case, I'm gonna use this symbol to cut off a part of the line. All right. Number 4, all points should be plotted correctly and the graph should make use of the available space. In other words, if you have a coordinate system like we have right here, your graph should not be located all of it like in this corner right here, because it would be incredibly hard to read. So we would make sure that we're using all the space available, so it's gonna be nicer to read. Okay, let's move on to example 11. It says the table below shows the total distance, including reaction time and deceleration time. It takes a car traveling at various speeds to come to a complete stop. So we have speeds in miles per hour and then stopping distance. Now, in order to find the input and identify the input and output variable, we should ask ourselves, which variable is dependent and which variable is independent? In other words, does speed depend on the stopping distance, or the stopping distance depend on the speed? What comes first? And in this case, I think we will all agree that the stopping distance depends on the speed that we travel. We don't select our speed based on the stopping distance, right? So the stopping distance is determined by a speed. So therefore, speed is going to be independent variable and stopping distance is dependent variable, which depends on our independent variable, which is a speed. Okay, so the input value then is speed and the output value is stopping distance. If, in other words, if we know speed, could we kind of guess what the stopping distance gonna be? Okay, so next we need to identify the lowest value and the highest value for our independent variable. Well, obviously by looking at these numbers, we could identify the lowest value being 15 and the highest value being 80. Now for output variable, the stopping distance, again, looking at the values, the lowest value is 44 and the highest value is 481. So next we have to basically set up our our axes. So your independent variable will always be the x-axis. Okay, so we label it right here. It's a speed, and the units that we use is miles per hour. Now for the dependent variable, that's always going to be our y. That's stopping distance. So I am labeling it and I'm labeling the units in which the stopping distance is measured. All right, next, what I had to do, I had to pick the unit, right? So when I pick the unit, I look at the values that I need to fit. My lowest value is 15, the highest value is 80. So if I start with a 0, I need 8 equal units. If I decide my step to be 10, step 10, I will need 8 steps. So that's what I did. My one unit step is 10. So I have 10, 20, 30, 40, 50, 60, so forth. And 80 is my highest value. I do have some room like here for 90, but that's about it. So I stopped above 80 a little bit. Now, what about our dependent variable? I need to fit values between 44 and 481. Okay, so I was considering 2 options. Just go by 100, make one step 100. So I need to go up to 500 about. So the 481 rounds to 500. So if I choose a step of 100, that I will need 5 steps, okay? But another option would be to go with a step of 50. So if I choose a step of 50, I'll need 10 steps to get to 500. So, and I counted my room and I decided that I do have enough room to make that happen. So my one step is 50, and I can let's just double check if I'm correct. So 50, 100, you know, I think I messed up here because this is going to be 150. So 200 should be right here. This is 200. Okay, now it's kind of hard to see. Yeah, I had to move all my numbers up a little bit because I skipped a portion right here. I marked the 200 wrong. It should be here. So everything kind of like moved up. Okay. And also, usually these numbers are on this side of the y-axis to leave room for making plots right here. So basically, try not to make this side of the y-axis crowded. Okay, I failed. But the goal is not to make it crowded. Okay, so let's go ahead and plot our points. Our first point is 1544. So, okay, 15 is kind of obvious. Now for the 44, this is 50. That means here's 25. Well, 44 is like below 50. So about here. So that's going to be our first point. Our second point is 25 and 85 with, well, 25 is easily identified. Again, this is 30, this is 25, 85. Okay, so I have, this is 100. This is 50, this is 75. So 85 is gonna be about here, approximately. I'm eyeballing it, okay? So that's my next point. The next point would be 35 and 135. So 35 is right here, and 135. Okay, this is 100, this is 150. 135 is not in the middle, it's like right here. It's about closer to 150. Okay, then the next one is 45 and 196. So 45, 196. So it's almost 200, but not quite. It's like below it. Oh, 200 is right here. It's gonna be here. Look at this nice data set. Can you predict where the next one will land? Okay, so 50 to 29. 50 to 29. So this is 250 to 25. So 229 is gonna be somewhere here. Above 225. Okay. Next, 60, 304. So 60, 304. So 304 is right above 3,000. I mean 300. Right above it. It's just like almost on the dot, almost, but not quite. Okay, next one, 75, 433. So 70 is right here, 75, 433. So this is 400, this is 450, this is 425. 25, 50, 33, kind of in the middle. So that's my point. So 75. And the last one is 80 and 481. So 80 and 481. So this is 450, 475. So 481 is gonna be above it. All right, so there we go. So we have these points. By the way, only points are part of the graph and the axes. These lines that I drew, this is for, those are helpful for you and me to see the corresponding values, but they're not part of the graph. They don't have to be there. They're just for convenience. All right. So I hope this was helpful. And this is it for this section. I'm gonna go to the next video for the next section, 5.6.